Page 537. Module 3, Topic 2, Lesson 1, Constant Ratios in Right Triangles. And I also have our paper that is our self-reflection. And I want to remind you that we're talking about naming the sides of right triangles in terms of a reference angle. That's the big vocabulary word. And then we're going to develop the relationship between side length ratios and the reference angle. We're going to do that in right triangles, a 45, 45, 90 right triangle. So let's take a look at it. I have a protractor with a ruler on it, and I'm going to use the inches side of the ruler this time. And let's go from there. Also, have your calculator handy because we're going to need to figure out if the ratios are equivalent or not. And that sometimes is more helpful when you have like decimals instead of writing down, the fractions themselves. Consider triangle ABC, which is a 45 degree, 90 degree triangle. Consider. Number 1, choose any point along the hypotenuse of ABC and label it point D. Then construct a vertical segment DE connecting the side AC so that DE is perpendicular to AC. Label the other endpoint as E. I'm going to do that somewhat in reverse because I want to make sure I have a 90-degree angle more than I have this side. So that's actually like, don't do that yet. Let's make sure we have the 90-degree angle first. And to do that, I'm going to use tracing paper. No, I have my protractor. I'm going to make the 90 degree off of this. First of all, let's make side AC. So on AC, I need to put a dot on there. With the inches of the protractor, I'm going to make a mark that is 3/4 of the way along. Now, one thing I don't like about the protractor's corners is somehow they get broken or they get rounded, so then they're not really accurate to start at 0. But if I just slide it up so that from A out, I have a mark, like I'm going to go from here, and instead of saying I'm going at 1 becomes the start, and now I'm going to count out 3/4 of an inch. Let's go a full inch. Let's go 1 to 1. So from 1 inch to 2 inch is a full inch, and that's the mark that I want to make here on that side, 1 inch away. Now the reason that I have it marked from 1 to 2 is because the 0 was so like off-putting. This is going to be point E. Now I want to make a vertical, a 90-degree vertical mark from there, and the protractor is perfect for that. So take the protractor, put the hole of the protractor on E, and then we're going to swivel. What's the best place for the glare to go away? Maybe up here. I don't know, I'm trying to find that right spot, but it's just not working. Right there's probably pretty good. So the protractor has these 2 lines that go off to either side of it. If you get a different protractor that doesn't, put it back in the bin and grab a new one. Now I'm going to make a mark at 90 degrees because perpendicular means 90. From here, directly trace a line straight up. Okay? And then now I'm going to put a mark D on this triangle. Right here on side AB. And then I'm going to draw that triangle in. Now, if I did it right, yes, I did that right. From 4 inches to 5 inches, the dots go from E to D. This side right here, because of 45 degree, 90 degree triangles, this 1 inch and this 1 inch should be the same. Now, I should also, while I'm here, measure side AD. So line up my starting value, and then I go from 4 to 5. That's a full inch. From 5, it's not quite 5 1/2. It's like 5 1/4. No, that's 5 1/8, 5 1/4, 5 3/8. I'm gonna say 5 7/16. Oh, 5 7/16. No. Line it up. Do better. Here we go. Okay, so this is a full inch. I kept saying 5. That's why I'm kind of tripped out for a minute. So from here to here is a full inch plus 1/8 plus 1/4 plus 3/8 plus 1 more 16th. That makes 7/16. 1 7/16 inch. Okay. I want to do that for side AC as well. I'm going to switch to, grizzly colors. Go to red. So from this one, still measuring in inches. Let's do the same thing. Let's go from here out. So I'm measuring right there at A, right there. That's actually a little longer. So AC is 1 inch, 2 inch, and a 1/16. 2 and 1/16 inches. And then on the side, it should be the same because the sides, the legs of a 45, 45, 90-degree triangle do the same, and it does. From there to there is 1 inch. From there to there is 2 inches. It's a 1/16 of an inch longer, so 2 and 1/16 inch. Then the last one is to measure AB. And we have to do all of this measuring because we're going to use this numbers. We're going to use the numbers here to make ratios, and we're going to evaluate the ratios. Okay, so 1 inch, 2 inch, not quite 3. So 1 inch, 2, 2 1/4, 2 1/2, 2 3/4. Looks like 2 7/8. Looks like it's right here on the 7/8 marker. So 2 7/8 inches to go from there to there. I needed all of that set up. You need to practice measuring and making markings on shapes. That's just like a life skill. But now that we have that, we can write the ratios of the sides. So let me stick with the color, black for the smaller triangle. And let's do ED to EA, which would be the measurements 1 inch to 1 inch. The nice thing about writing it's like this, the inches will actually cancel, so we're left with only a number, and it happens to be the number 1. Let's do another one. Let's do ED to AD. ED, AD. This is also done intentionally. I'm going to highlight this green. I'm going to highlight this green. I'm always going to put the hypotenuse. That's what this is. That's a 90-degree. That makes that the hypotenuse. I'm always going to put the hypotenuse on the bottom. Okay, so 1 inch over 1 7/16 inches. Inches will reduce, and then I need to figure out what 1 divided by 1 7/16 is. Hey Siri, what's 1 divided by 1 7/16?
1 divided by 1 plus 7 over 16 is approximately 0.6956.
I'm going to round it to 7 because 6956, the 6 rounds up to 5, the 5 would round up to 9, the 9 rounds up to 6, so 0.7. This is also going to be the same if we do the other one as well. So this is actually equivalent to EA over AD because both of these fractions have a 1 in them. So I get 2 for the price of 1. There they go. Let's talk about the big triangle now. And let's do AC over BC. So that would be 2 1/16 inch over 2 1/16 inch. Inches reduce. And then the number would be 2 1/16 over 2 1/16. When you have a fraction where the top number and bottom number are the same, the answer is 1. Yo, the answer is 1. So we have the small triangle creates a ratio of the legs of 1, and the bigger triangle creates a ratio of the legs that's 1. That's on purpose. I hope you heard what I just said. That's the important thing of this whole lesson. Okay, let's do the next one. Let's go leg AC over hypotenuse AB. So that'd be 2 1/16 inch over 2 7/8 inch. Hey Siri, what's 2 1/16 divided by 2 7/8?
2 plus 1 over 16 divided by 2 plus 7 over 8 is approximately 0.7173.
It rounds to 0.7 also. Check them out. We get the 0.7 ratio from hypotenuse on the bottom. That's the key thing for both of these. And there's that equivalent fraction. This is the same thing as BC over AB because BC and the two sides that are both 2 1/16, when we put them as the top and put this number as the bottom, we get the same ratio. This means, therefore, all of you watching, thank you for watching through to the end here, you know, come on now, don't lose it. You know that the hypotenuse of a right triangle is the side that is opposite the right angle. Did you know that? I'm going to highlight hypotenuse as green. So the hypotenuse of a right triangle is the side that is opposite the right angle, which means on this diagram, I'm going to outline yellow. Okay. In trigonometry, the legs of a right triangle are the opposite side. So opposite side is here. And the adjacent side. Adjacent means next to. Hey Siri, define the word adjacent.
Adjacent means next to or adjoining something else. Do you want to hear the remaining one?
No, but I do notice that there's a geometry of angles saying having a common vertex and a common side.
Here's what I found.
There's always more to look up. Please use your resources. So the opposite side would be the one that's yellow. It's the side opposite the reference angle. And reference angle is such a crucial vocabulary word. That's actually what you should start with first. Identify the reference angle, and it means that little vertex of the triangle. And by the way, never the 90 degree. The adjacent side is the side adjacent, aka next to the reference angle, but not the hypotenuse. The hypotenuse will always be the side across from the 90-degree angle. Last of all, trigonometry is a branch of mathematics that deals with the relationship between sides and angles of triangles. That's literally what trigonometry means. Three-sided measurement mathematics. There's your lesson in Greek today. Thank you guys for watching. This page has been page 537. Activity 1 continues because we want to talk about the side lengths and the ratios that are created for any type of triangle. But thank you for watching this video. Thank you for watching this episode, and I'll see you in the next one. Like, comment, and subscribe. Have a good one.